showed up, and he'll be back after 11, or he'll be back before 11, and he'll deliver his talk. So the other thing is Mr. Chen, who
Hello. Hi, Kevin. It's been a
pronounce
while.
your first name for us, please, for those of us
So
that
it's
are
a weird thing. It's a weird
transliteration
thing.
illiterate.
Yeah, I think if you remember when I was here a few years ago, I went by the name Sean. Um, but the thing is, Sean has three spellings. So for a while, I just switched back to this name Zhu Yang. And then now, because I'm in university interning, and I've got a job now, I changed my name to Lucas. So you can call me Lucas if you want, or you can call me Sean, or you can call me Zhu Yang.
Okay.
It's a
What's
it's
your?
a weird thing. Well, all
It
three of
sounds
them
weird.
work, but
You'll
yeah,
have to give us a presentation on translating Chinese language to our spelling. I gather there are three different systems for doing that.
yeah, it depends on where you are on the mainland or in Hong Kong. But I've grown in the States in California for quite a while, and everyone has their own way of saying it. So at this point, it doesn't really matter. Anything
So,
goes.
so X is Z, and then it's easy. Su Yang. X is Z,
It's
right?
it's Xu Yang. It's Xu.
Oh, Shu.
But that's not a sound you have in the alphabet. There's no 26 letters with that sound. So Zoo is kind of like the compromise I make. But it's
Yeah,
nice to meet you, Don. It's been a while. It's been a while.
Yeah, great
I
seeing
know
you
there
again.
are.
It is good seeing you.
I
Yeah,
Hearing from you. We can't actually see you.
no camera.
yeah. I'm trying to get my camera up. I
Okay.
had a talk, but I didn't really manage to get any code going. Um, really, stuff that's been on my mind lately is I'm interning at a startup, actually back here in the Bay Area, doing a lot of robotics. And so the talk I was gonna give was kind of related to that stuff I've been doing. You don't always get a lot of stuff in the robotics industry world that really relates to Fourth, but once in a while you do get something. And that was the talk, but I'm not really ready to give it yet.
All right.
Well,
We'll look forward to it for next month, hopefully,
before we move on,
or when you're ready.
so Zhu Yang, I met him in the fourth group. I don't know what 4 years ago or something, and
Yeah, it's
he
been
got
4
it.
years.
Yeah, it's been a while. You were in high school when you first showed up.
Yeah. It was like 10th grade. 10th grade. Now I'm a sophomore, rising junior.
Yeah.
That's
So we got him a job at Redwire, and he kicked ass.
Oh, well, I wouldn't say it so confidently, Don. I think I did well. I did well.
No, you don't understand. This is one of your first jobs. Redwire was not run very well. Okay, they didn't use personnel as they could have. They let me go. There you go. After I designed their
Yeah.
Argonaut computer, you know. But anyway, yeah. So now Kevin French was awesome. So I hope you learned something from
Yeah,
him.
Yeah.
Yeah.
No, Kevin was great. Kevin was like it was like the little bubble where anything could happen and everything was magic and ponies and stuff. Yeah, Kevin was great. Kevin was good team lead, good programmer, was really patient. He was basically my mentor for all 3 months. Kevin was great. Yeah, now I'm at Dusty now. It's a very small robotic startup actually in Mountain View. So that's why I'm back home actually. Uh gonna be back until like the 15th of next month.
You were in the
Oh,
robotics team at high school. And did you
yeah.
meet us at Maker Faire? Wasn't that your first organizational exposure?
Yeah. It was looking back, the robotics team was really just little leagues. We weren't making money. We were actually at a loss. Didn't have any sponsors. It was just a bunch of kids messing around with power tools, really, and a lot of software. I met Ting at Maker Faire at one of your booths. I think there was some fourth code lying out. I don't remember what it was, and first thing I said to Dr. Ting was, it looks a bit like basic. Uh, and then of course Dr. Ting being Dr. Ting, he kind of took me through it. He explained it. He was really patient, and that's kind of how it led to all this. He actually invited me to one of the Saturday meetings. I don't know how long ago, and then I kind of joined for a year or 2 years. I think I came almost every month, and then I went to college in the Midwest, and so that kind of tapered off. People with good memory might remember the Move Forth talk. That was the talk about the forth that compiled to a modern assembly code with all the with LLVM, which it was a library that is used in like most C++ compilers, and I figured out how to like Frankenstein the two things together. Um, yeah, now I don't have that much free time anymore. It's really tiring, a lot of work, 8-hour days. I mean, it's probably normal for all of you, but uh, I can't imagine not taking a nap a few times a day. That was college life. Yeah, that's all.
How's
I'd love
school?
to make house school. I'm a computer science major. That's actually a lot more common than maybe back in your time when you guys were in college, but it's all right. It's pretty easy. A lot of
I hear
people.
it's all the rage these days.
I'm sorry.
I
I'm
hear
sorry.
it's all the rage. Yeah, I hear it's
Yeah,
becoming so much
yeah,
more popular.
yeah. 400 person lecture halls, 400 CS majors, one professor.
Wow.
It's crazy. It's like you're on your own. Like if you can't Google stuff, you can't use a reference manual, you're dead. That's how it is right now. Yeah, but I mean, it's going pretty nice. I think the job is a lot more intense than the school. School is, you have to go at the lowest speed of the slowest guy. Work is like everyone just moves forward, and if you're left behind, you get fired. You know, it's kind of more of a joke than anything, but it's great. It's great. A lot of smart people, a lot of people who have been in the industry for like 25 years, and then just everyone in that same room. It's a lot of pressure, honestly. Yeah. And robotics now, it's not really just one executable, like one binary file that runs the whole robot. It's like a collection of things. There's very complicated compiling steps. We use containers. Thing that's all the rage right now is concurrency, actually. I know in school most people just learn a bit about threads, but they don't really use it in practice. But in robotics, we use many, like 20, 30 separate processes going at once. And then the synchronization between that is a big deal. Uh, One thing that's really important, at least for my company, I don't know about the industry, is we run everything at very fast refresh rate. Um, so if you have threads going, then latency becomes a big problem. And like every time I hear talks about from SVFig, it kind of shocks me because like the GA144, that was a solution to that, but that was before everyone was really caring about threads and concurrency and stuff like that. Yeah. Anyways, I can make more idle chatter at the end. I don't want to take up everyone else's time.
Well, Don said that Dimitri isn't around, so I'm hoping Don is going to talk about his LinkedIn AI and robotics group, and also perhaps a few words about this YouTube video that he touted on our email list, on the SVFig list.
Okay. Share my screen here. There's entire screen here.
And when is Dimitri going to be back?
It should be any minute. Can you see my screen?
We can see your screen. It looks like Bob's.
Yeah, okay, that's good. Let's see, let me close some of this stuff.
Always a good idea.
Let's see. Let's get to add too much stuff. So let's go to. So LinkedIn. As you know, when I've been talking about the CORE I project for a couple of years now, and one of the things that a lot of fourth people didn't quite get was, why are you doing this? Why are you putting down interpreter compiler in, on the chip, just make a meta compiler and that sort of thing? It's because I want to build a killer app. A killer app being a single chip AI computer on a chip. And so about 3 weeks ago, I created a group called AI and Robotics. We have 682 members. We get a couple dozen new ones a day. We've had 3,700 people come and look at the site. We've had 20,000 post views. So that means a post view is they actually clicked and looked at a comment. Now, this is in 3 weeks. The people that are in this group, let's take a look at them. And Brad, I sent you an invite. I don't think you did it yet. And everybody in AM Robotics needs to sign up. So look at some of the people in this group. These are the top of the top of people in AI. So I've been doing searches on AI and robotics, and I've been inviting people to the group, and you can see that there's all kinds of AI people. There's you can come on the group and you can look at this yourself. You just click over where the members are. So the goal of this group is to talk about AI and robotics. And gee, you guys remember that talk? So when I first started the group, it was only me, but I have the Facebook group too, and the Facebook group. Let's go take a look at that group. The Facebook group has been going for, I don't know, 6 months, 8 months, something like that. You'll notice there are there's quite a few fourth people. 255 members. So this group is 8 months old, and LinkedIn is 3 weeks old. It's a baby, 682. And the difference is the fourth group, this one, is mostly makers and fourth people, whereas the LinkedIn group are real researchers in this area. The point is, AI is the killer app for fourth. I believe that for many years. I believe that for 20 years. I built Whiskers AI on top of fourth with using Max Forth. And the things I did in that, I would have a hard time doing in C, really would. The triune architecture was easy to build in a page of code, maybe, something like that. So as we scroll down here, we can take a look at some of these. What I want to show you is the number of impressions. So let's take a look at this for a second. Okay, so here's something I put up there, and we got 369 impressions. So take a look at the impressions on these things and topics. I want to get down here. But what's kind of interesting about this is when I gave talks, Oh, this is kind of interesting. I made this video promoting AI and robotics from one of the new AI video places. So there's a link to it where I created this video. And I did it in a matter of minutes. And there's almost 800 impressions of that one. Let's scroll down. You'll notice there's 300 impressions, something like that. I want to come down to a talk that I gave. So I think what's important about the group is more interested in, and everybody, we're going to be using this a lot in the talk today, Dimitri and I. This is the AI to use for code. This is amazing coder. Claude AI will create fourth code and sometimes not make a mistake or get you 90% there. Especially for new people, start with Claude, and we're going to go through that. See, there's over 1,100 impressions on that one. I want to get back down here. I like this one. This is one of the posts that I did. So a new member asked me how I can help. I answered, comment, educate, explore ideas, learn. And I got an angry Johnny 5. He got 1,000 impressions. But anyway, what I wanted to get to is a talk. So here's a talk on the CORE I project. I got 1,000 people watch that. How about that? So one of the things that it needs, we need you fourth guys, because we're going to be talking about fourth a lot with the CORE I project, but people like Bill Ragsdale and Brad and all the rest of you guys, Dennis, needs to be educational resources in the area of fourth on this group. And you're going to be teaching some of the top people in AI. I signed up for LinkedIn, for their what do they call it? Their paid subscription. I pay $60 a month. So I'm able to connect with like 250 or have connection requests, 250 people a week, about 1,000 a month. And, maybe a quarter of them join or 20% or whatever, but it's pretty substantial. So I'm going to be focused on AI and machine learning and robotics, and we're going to get professional people. There's CEOs, there's presidents of companies in here, there's CTOs, a lot of people. So if you want to help get fourth out there, especially in the area of AI and robotics, you need to join. And if you're not a member of LinkedIn, it's free. Just create an account, and then if you do a search on this, you'll get to it. Or if you have my email, you can send it to me, or just connect with me. Now, what's interesting about groups, when I went out and chose the name, all these names have to be unique. Isn't that nice? AI and robotics group. Well, I tried to get AI and robotics, and somebody had used that. So I had a group to be in, and that made it unique. So fourth is the killer app. Fourth's user interface is a chatbot. So we started with the chatbot 60 years ago, and now the whole computer industry is using a chatbot interface, which is fourth, right? It's free. With fourth, you get a free chatbot. So this is really where I see as a turning point in fourth. I have spent an enormous amount of my own personal resources on the CORE I project now. I've given many talks on it. I finished the board finally. I got all the errors done, and it's ready to go out. I want to do a sanity check though. So I'm just going to show you the final board here.
So you say you've got all your errors done. When are you going to have the fixes?
No, the fixes are done. The fixes and errors. It's ready to go to fabrication. What I want to do is a sanity check. So I created some of these footprints. So what I do is I print out just the top. First, I do a printout on a 1-to-1 ratio. So this shows the top pads. I print this out and I buy the part and I drop it in there. Like I made these parts here. So I want to make sure that I didn't screw up and use the wrong footprint. And that's the only thing holding me up on making the board. So I just.
Do you have a list of folks to whom you're going to make this available?
No, I do not have a list. It's people that tell me. So if you tell me you want one of these boards, let me just tell you the process first. So we're gonna fab the board, and I should have the board back by the next meeting. I gotta check power first thing, and then I have to make sure I can JTAG the FPGA and the ESP32. I put a very nice ESP32 on there. It's the one with the 8 meg of pseudo RAM on it, so it's the more advanced one. When you can plug in a USB port and bring up Arduino and program that with Brad's fourth, and then we can bring up you plug in the USB, to the Lattice FPGA, and we can program that. We're off to the races. We have a basic board for people to build and experiment with. I am going to have to write basically a device driver for the SRAM and the flash and the SD card. So I'll start with the SRAM. I'll get that running first, then flash, then the SD card. I always envision.
For the purposes of the YouTube video, and for those that are actually physically present, you want to make an offer for folks that want this board to contact you, to encourage them to contact you at this time, or you want to put that off until later?
Yeah, so you can contact me at donaldrgolding@gmail.com. My cell phone is 310-691-4312. And anybody that gets an early, these things aren't going to be free, but I will probably let you have one for like $20 over cost. We're going to do a crowdfunding campaign on crowd supply. And I see that these boards are pretty popular with FPGAs on it. I think there's one other board that has an ESP32. They're going for about $149, and they've generated over $100,000 in sales. And that will be the price, when we do that. But I'm not going to do that before I've tested everything, which means all the device drivers have to be done. So we're probably not going to do the crowd supply until the fall sometime. The October, November timeframe, maybe. So it would be an opportunity to get in on the ground floor. If there's any issues with the first board spin, I will replace it on the next board spin. If we find something, wrong with the board, I give a free replacement. And if it's only Dimitri and I going forward with this project, it's going to go way slower. than if you guys get on board and start helping out. I've given a lot of talks on the architecture. Go back and look at the videos, but there's some really powerful things about this. I talked about the flash. So this is an interesting computer. So it's not just a RAM, CPU, hard drive architecture. It includes flash, and it's high-speed flash. So although it's a tenth of the speed of SRAM, it's still faster than DDR4 memory when you have a page miss. So the flash is actually going to be your longer-term memory for your AI, for your robot. You can store compiled code. You could extend the dictionary into it if you wanted to. One of the things I had using the flash is you could put dozens of snapshots of SRAM into the flash. So, and when you use the magic word called remember that Brad put in his fourth, and I was bugging him early on. I love that word. So when you type in remember, you pull the power, you power it back up again. You're exactly where you were, where you left off, because what will happen is it'll save a snapshot of SRAM into the flash memory, and on boot up, if there's a if a flag is set in flash, that there's a default configuration, a default snapshot. It'll load the snapshot and you'll start where you left off. So there's Arduino headers. So all those different shields out there, you just plug into the board, start programming.
There's a company I saw called Industrial Shields that's making commercial quality for actual embedded systems, automation stuff. Makes the whole idea of producing stuff with Arduino a little bit more palatable to actual businesses and people that are going to make products. And speaking of boards, if I could take a little side trip, I wanted to say we have an actual genuine collector's item whiskers board from the early days of Don.
Oh, really?
Courtesy of Dr. Ting. If anybody wants that or any of the stuff that they saw last month, please get in touch with me. I'm Forther, Forther, at Comcast.net, or you can get me through MeetUp messaging. If you don't succeed the first time, send me another. Sometimes I get your messages lost in the queue and fail to process them. If I haven't acknowledged within 24 hours, I'm not going to acknowledge any individual message. That's a basic of email etiquette. Don't expect an answer before 24 hours, but if it's longer than 24 hours, something's gone off the rails. So, don't you want a whiskers board, any of you, besides Don?
I have one. I have a whiskers. I need to charge this battery and give some demos of the three-tiered architecture. So one of the things I've been doing is, since the 90s and I created whiskers, I've been, a big fan of AI, and even called my first company AI Engineering. AI today is blowing my mind, and there's a new AI on the block that you guys, and this is going to be the talk that Dimitri was going to do. He had an emergency call with his brother, and I guess it didn't go well. I don't know what's going on with that, but Claude AI. So if any of you tried to get GPT or Bard to write Forth code. It was pretty crappy. It was amazing how crappy it was. So I ran across this new one called Claude AI. It's free to sign up. There's no monthly fee, and it will increase your productivity by a factor of 10 in whatever you're doing. Let me show you why. Okay, so we had a guy on Forth 2020 or my AI Facebook group who asked ChatGPT to write a program to print from 4 to 16 to the screen. Okay, so he did that, and look, it was terrible code.
Did it work?
No, it did not. Now, I was blown away about that's Python. No, I said write Forth code. Don't make me a liar here. Write Forth code to print for numbers 4 to 16. Okay, you know what I think it was? I did it this way. I said write code in Forth. I think that was different. So syntax is important with these AI guys. So let's take a look. Yeah, this is the one. And it's also commenting on the bottom. Take a look at that.
It's kind of an odd choice of a way to do a loop, but okay.
Yeah, well, let's see. I want to show you that the thing that really blew me away was it actually wrote this code using recursion when I did it. Let me go in there. So I'm not really giving a talk today. We're going through how to write System Verilog code and Forth code. Let's see. Where's the search tab in here? Search both. There we go. Forth. I want to show you the first code that it ran because I was blown away. I mean, I couldn't believe it. Come on, where are you? Oh, here it is. This one. I really like this code. Check this code out. Now, yeah, I know, guys, we'd use a do loop, right? But it works. So I took this code, right? And I brought up WinForth. And I copied and pasted it. All right. Look at that. It worked. And it used a more advanced Forth methodology, which is recursion. I think this is incredible. This is the first AI that can actually code in Forth. So today, Dimitri and I were playing with this before our before the talk today because we wanted to show you guys, this is the main thing we wanted to show you about both System Verilog and okay, so here's another one.
If I may interject,
Sure.
the idea that that was wonderful is actually absolutely atrocious to me. Anybody that uses recursion without actually needing to, one of the whole basics of forth that a lot of people don't get is to produce stuff that works. And one of the basic tenets of doing that is correct by inspection. And anybody that can look at recursive code and say, oh, I understand this and no problem, and just glance at it and say, oh, yes, that's correct. The idea of using all of this stuff that is not necessary to the final goal is, how shall we put this, unforth-like, in my feeble-minded opinion.
Okay, well, that's not the point, actually. The point is, it knew enough about forth to even know that recurse was in it. That's my point. This is not the way that I would do it. I'd use the do loop, right? And most of us would, right? 16 for do, you know, I dot loop, right? That's pretty much it. All right, I just told it to write an expert system in forth. How about that? So it's not going to give you exactly what you want, but boy, is it good at getting you in the, you know, some code to play with and get started. I am blown away by Claude's ability to write forth. Forth is a very obscure language in as far as today goes. You know, this really ain't that. So, you know, I'm sure there's a couple of problems with it, but it even knows about cell, you know, that's a more advanced, you know, I mean, it's a more modern forth term. Early forths didn't have cell, not, you know, F83 didn't have cell. So it's really not bad. You can sit down here and have it write all kinds of different forth code. Brad, I see you looking at the screen. So let's say write expert system in System Verilog. Now notice that it also tells you about it down here. It tells you what it did and why it did it. Probably what I'm most excited about is not writing forth code. Is it's actually this in System Verilog. So here's an expert system, you know, written in System Verilog. And here's what I want you to imagine. You're using the Core I board, and you say, okay, I want to write an opcode. How about this? Okay, let's try something. Now I haven't tried this one before, right? Fast. How do you spell CORE AI? CORE. Come on, Brad. CORE AI transfer.
FOUREIR. FOURREIR. Oops, no, shit, that looks wrong too. Okay, I can't spell either. Oh, it's flip the I and the E. Yeah. It'll probably understand you despite your spelling errors, given how these LLMs work.
Oh, let's try it in forth first. Now I would expect it to blow up on this one, but let's try it. Let's see what it does. You notice it knows create.
It reminds me back in my youth when we were making spectrum analyzers and we used a bifiller wound Fourier transformer.
And it even documents the code down here. So let's take a look at this. I've never tried this. If any of you math wizards are out there, you might take a look at this. Boy, it sure likes to use recurse, doesn't it? For its loops. So
I'm suspicious. for one thing, in that loop up above, it's using I, but then it's not. Actually, no. Let's see. Twiddle converts. I don't know.
There's I.
Yeah, no. It's using I, but then it's not right. It's doing float ops, and then.
Okay, so my point is this: it's not necessary. You're not going to necessarily write a whole app. You know, you're going to have to do some work, but this would gives you a great start, doesn't it? Now, maybe you don't like this code, and you know rewrite Butterfly, and then you interactively test it, and you go to generate twiddles and blah blah blah. But if you try this in GPT or Bard, it's going to look like crap. It's really going to be terrible. Claude is incredible. So and then it explains what it's doing down here. So let's try something else. Let's say right. SHA to 256, right? And can't type for shit. Never have been able to. Okay, so you're sitting down with the Core I board, and you want to do Bitcoin mining. So you need to have an opcode that does this SHA 256. So you sit down. And it writes the code out for you. And I've never coded SHA. I don't know if this is correct or not, but like I said, what it does, it's great at giving you a starting point. I'll give you a second to read that if you'd like.
So one question: how does it do? I mean, are there enough examples of Verilog out there on the internet that it could learn the syntax to the language? And because aren't these things like statistical, like what word follows this other word, and in this type of context? Or well, I guess the experts in the field don't really understand how this really works or why it's working.
I probably watch over 6 hours a week in AI videos where it's top experts in the field are talking about AI. They don't know how it comes up with this stuff. They just feed it trillions of bytes of data. It scours the internet and it learns the stuff itself. So basically, what you would do is you don't need the module input and stuff, but you do need this. So, basically you would copy all this code, you would paste it into our code, and then you would create an opcode with it. Always statements. So remember that FPGAs are parallel computers. So when you have an always statement, that's a parallel process. So you would add another parallel process to the Core I computer that is only calculating SHA. So whenever it gets a new SHA to calculate, this thing would trigger, and in parallel to the operation of your main loop, the fourth computer, to calculate the number. So the way that you do this is an always statement has to drive. So a register can only be driven by one always statement because it's literally creating hardware. You can't drive like two outputs from two sources, right? They'll fight each other. So what you wind up doing is you create registers and you have an input. So every always statement, think of it this way. Every always statement, you create an input register. So that'll be the raw data, or it's an array. It could be a string or array or something. But anyway, it's a registered chunk of data. And that's your input. And then your output, you know, you make it a 32-bit register, or it could be another array of data if you want. And then you always put a flag at the end of it. So you're going to create three registers: an input register, an output register, and a flag. So the flag is a semaphore in parallel computing, in multiprocessing. And so at the beginning of the opcode, you set the flag to false, and then at the end of this always statement, you set the flag to true, and then now your fourth computer is going to be in some sort of main loop, and it's checking all these flags as it goes through its main loop. Says, oh, the SHA code, SHA processing finished. I'm going to grab that and I'm going to go ahead and continue processing, you know, mining Bitcoin, you know, because it needs the SHA function. And so the Core I, we've talked about using multiple cores before, but it's not really the most powerful and efficient way to build a parallel computer. Sometimes, because when you build a core, you're going to consume about 1,200 to 1,500 LUTs. So that means whatever the functionality of the processing of that core, if you can do it in just a straight always statement, or maybe several always statements with System Verilog code, you probably use less LUTs and it'll run even faster than a dedicated core to that. Now, in a computer architecture, I can see using a core for the display, use a core to manage the flash memory, and a core to manage the SD card. I really can't think of too many times I would use more than 3 cores at building an embedded computer. But because I would do all the rest would be always statements, would be, you know, creating custom opcodes and creating these always statements. And now you have a massively parallel machine, because you can have literally hundreds or even 1,000 of these parallel processors all running simultaneously at the speed of silicon, which is about 250 megahertz in this FPGA I'm using. So it's actually faster than running a core. If you had some sort of even a huge mathematical problem, you want to do parallelism, I would still do it this way. I would still, create the 3 registers: the input, the output, and the semaphore, the flag register, and have it do this massive parallelism. So I'm expecting this board to just smoke a modern day computer, especially in areas where in areas that can be processed parallel in nature. One of the things that Dimitri and I were talking about as a demonstration of the Core I system is, what's the name of that game, right? Is it Dooku? Dooku?
Sudoku.
What is it?
Sudoku. S-U-D. God, I'm not gonna spell it right. Sudoku. S-U-D-O-K-U.
S-U-D-O-K-U. Dooku. Let's do it in fourth first. Now, if anybody out there decided to write Dooku in Forth, wouldn't it take you a week or two? Yeah, I mean, just to get it started, to get kind of the template of the code written. We just did it in what, 30 seconds? So, and here again, I'm not saying this is copy and paste. I don't, you know, there's probably some errors in here, but you know, it does create the functionality, you know, valid, find empty, solve, and you can interactively test these things, right? So now let's do it in System Verilog, and let's tell it to now, Dimitri and I were playing with this earlier today, interactively. Can't spell parallel. That's terrible. I think this is absolutely amazing. I know Brad has this at work, but I doubt if Google shares it. So, okay, so let's see what it did here. So like here again, we didn't test it. Dimitri just took a quick look at it and said it looks pretty close. So I think
it's doing the right kind of thing for sure.
Oh, there he is. Yeah. So Dimitri, you want to take it over?
It's at least hallucinating in the right vicinity.
Okay, should I share my screen then?
Yes. Let me stop sharing.
Right.
The master is here. Stop sharing.
Okay, let me share. Give me 1 moment.
And by the way, if you guys want to unmute your mics and just be interactive, that's fine. You don't have to wait till the end to ask questions or make comments. This is an open forum today.
Yeah, just like a conversation. So yeah, while you were doing that, Don, I just tried to put this right Sudokus over in Forth. Now, one of the things I found with these kind of AI programs is the results are sort of like non-deterministic. So you won't necessarily get the same result for the same prompt, not exactly the same, but it should do the same thing. And here's what it came up with for Forth. And I'm just going to look at that, see if that actually looks correct. So the main piece of logic here is whether this is valid.
Well, for one, it looks like it didn't. It failed to understand that the stack comment isn't a way to pass parameters, so it's referring to some of those by name. It looks like, which is that's the interesting thing is it seems to smush together different programming languages. That will a lot of these LLMs will kind of you know, they didn't quite know how to do it in one language, they'll infer the syntax from another.
So one of the other things we found is it'll call a function that isn't defined in Verilog, and then you say, please define this function. You give it the name, and it defines the function, and then you can copy paste that. And and put it in the code. So it's an iterative process.
No.
And you typically iterate with it. When you find a problem with the code, you can say,
Yep. Yep.
recode the solve parameter, and you made these mistakes,
Yep.
and it will
Our
fix
minds
them.
are linked. Our minds are linked. Mhm.
I'm not sure I understood that question. If that was a question we
Good.
got.
Were you saying something, Dennis?
I think he stepped away. Maybe mute his
I
mic.
don't want to read it, and it won't.
Okay. So one thing I was trying to try here is test, because sometimes you get some code and you're not really sure how to use it. So I like asking Claude to write some kind of test. So apparently this is how you might try to use it here. And so yes, it's initializing with some values, but I think it's good for getting the sort of outline of the program. What I find most fascinating actually when using Claude is not so much for simple bits of code, because of some of the issues we've like identified so far. But if you think of something that is like beyond what you thought could be possible, right, or something like a really big goal, it's interesting to see what it comes up with. So I might try to think of one now, but if anyone has a suggestion, one I think you can name it, just some. It could be fourth, it can be System Verilog, but some really big goal. So I'm going to think of one now.
But a Bitcoin engine.
Okay.
You might as well make money at it, right?
in fourth or System.
Both.
Both. Okay. Right. Okay.
Put a Bitcoin miner.
Okay. In System Verilog, that can be programmed using the fourth programming language.
Oh God, that should be interesting.
Yeah.
God.
Obviously, it is.
It might just do it in fourth. I don't know how it parses that. But we'll see.
We'll see. It might get it wrong, but
that'd make my brain hurt.
we did one earlier asking about Prolog, and I was actually quite impressed with that too. Nice. Okay, we have the result here. So bear in mind, when you do get this code back, it is usually quite short, and you might have to ask it to expand on things, but I'm always amazed that it will give you the outline, whatever you've asked it to create, however big it is. So here's one approach to implement a Bitcoin miner in System Verilog that can be programmed using fourth. So the inputs are clock, fourth instruction, which I guess would be CFA, perhaps. And the output is a hash result. So we've got a few things here.
Okay, so see where it says SHA-256.hash? See, it didn't.
That's like a module.
Oh, is it?
Yeah, I think, but it's not declared it, so we'd have to ask it to write that module for us.
Yeah, so show them how it would write the module.
Sure, I will.
Can we take a sec and try to establish for the feeble-minded program chairman what the goals are, and perhaps talk about wrapping this up in 10 minutes or so, so we can get to Brad's talk and then maybe to Chris's, and then maybe have some time at the end to chat with Lucas and Don and stuff. Does that sound like a reasonable question?
Yeah, we'll just finish up the SHA 256 because then it
Sure.
shows how you keep, kind of working down the problem. It starts at big picture, and then you iterate down into the details.
Okay, Googly lady, set the timer for 10 minutes.
Okay. We can say define module.
I think that'll just define the inputs and outputs.
Let's see. Let's see.
Yeah, we'll see what it does. No, it went further.
It has attempted to expand this. I think it's left some bits incomplete, but it's just showing you the pattern of how you would build that up.
So see the pre-process there? You would then ask it to write that function. And so you just keep going until you have the whole thing done. And then you go and start, debugging it. So the main thing we wanted to accomplish today to show you how to use this new AI programming tool that I think is very powerful. You can use it in your work, make it a lot more productive. You can go to Claude and start a project very quickly and maybe have something that works by the end of the day. Take a Saturday, something like that. It also, we wanted to show how you can use this to write opcodes for our Core I project. So, and then when we get to the open session, we'd like to brainstorm with you guys on where you think we might promote the Core I project during our open session.
So just to mention one thing too, regarding this, remember that the Core I was designed so that you can create new opcodes whenever you like to connect to new pieces of hardware. So these are pieces of hardware you can actually put inside, or modules that you can allow it to communicate with. And we even have some examples where we've gotten it to come up with opcodes that would control one of these pieces of hardware. So you can really accelerate the development of that, even if you're not too confident in System Verilog, because I think one of the barriers really is just plain old digital design, knowing how to design these things if you're not familiar with HDLs. Now, as you've seen, sometimes the code is incomplete and has a few issues. But if you were to give me, for example, one of these templates and says, Dimitri, could you complete this and fill this out? I'd be able to do that a lot faster than writing it from scratch, where I'd have to do the planning, figure out the outline myself. So really, this is a tool that really changes how we can approach these things. I was most impressed when I put in some prompts for the engine for Prolog, because I always thought, no, the only way that I would succeed with that is to write a CPU first with some instructions, maybe based on a virtual machine, but it was coming up with hardware that could directly evaluate all of these rules you'd write in Prolog. So that's the main thing really that we've been showcasing here. And I don't know if I lost my connection there for a moment. But yeah, so I'm willing to open to any additional questions or comments.
I'm wondering how well or badly factored a substantial fourth program would be. I've found in the past that if you don't start off by properly factoring a job, you will waste a lot of time and have to go back and refactor it.
I thought they did a pretty good job. It seemed to have one word for every major function.
We have one question here in the chat. Does the Core I fourth do floating point? And if so, does it use the hardware multiplier accumulate units on ICE 40? Don, do you want to handle that?
Yeah, so it does use they're called Macs, and if you look at the after you synthesize it, you'll notice that it uses a Mac. If you have the multiply instruction uncommented, if that's defined, it will definitely use a Mac. I, for one, don't believe in floating point. I believe in scaled math. And an interesting thing about asking these AIs to program, they'll default to floating point, and then I say, please rewrite in scaled arithmetic or integers, and it does it. So the problem with floating point, yes, you can go out and get a floating point package on GitHub. If you want to add floating point to Core I, be my guest. But floating point, like on a RISC-V on our space mission where we use the RISC-V, used 40% more LUTs than a normal RISC-V core. So you're going to pay in LUTs just to have it in a format that you think is more readable. Remember, this is digital logic. So you can have a register that's 128 bits wide. So why do you need floating point? You just make it more bits in the register, your result register. And registers are absolutely, consider them almost free because it's a register-based system, and every LUT has 4 flip-flops in it. So if you think about it, a 32-bit register is only 4 LUTs, right? And the FPGA that our standard FPGA is 25,000 LUTs on this board back here. So registers are cheap. I would just make the results register and the intermediate registers larger. You may and do it that way, and don't use floating point. You'll use way less registers. It'll run faster.
Yeah, I think that's a good point, Don. There is maybe one area I can think of, but again, I don't know much about this one right now. But some have talked about 8-bit floating point vectors, because, all right, so yes, the second part. If big fan of fixed point, but algorithms I have used floating point. Yeah, so I think there might be some areas in machine learning where 8-bit floating point vectors might be particularly powerful. But I think even then that would be like a custom bit of hardware that you add more than something that would exist at the instruction level, because you probably would do that just for the intermediate calculations and then round it up or round it down to maybe a whole number later. So I think that'd be something more in the middle than something built in, but it is completely possible to add that in if you like. You can add in a floating point stack, but yeah, we've not decided on that for the reasons that Don has said. We just support only fixed point out of the box.
There are occasionally use cases for floating point, but in general, in terms of simplicity and its daughter reliability, it's a can of worms that is best not to open. You've all heard me say that floating point is the work of the devil. I can prove it. The 8087 floating point coprocessor used to run really hot.
Well, the other thing is floating point is an approximation. Make the register bigger. It's exact. It's not an approximation. So just make the register bigger. Make it more bits.
I think a lot of the cases where folks will use floating point and think they needed it, it's really what they need is something that's in log scale, and then sort of they need the dynamic range, and that if you've got the hardware and that's like the easiest way to do it, it makes sense maybe, but yeah.
Yeah, and like I said, if you have a use case for it and it makes your job easier, certainly use it. But if you're doing your own coding, or if you have a library that uses floating point and you don't want to convert all that source code, that would be a reason. But you could, and one last thing I'm going to say about the Core I is you have plenty of LUTs. You could put a RISC-V inside, although you would need a separate, DDR RAM. So we would have to spin the board to put a RISC-V on there, unless it just has a little bit of memory. Like if you wanted to have 6K of memory in a RISC-V, you could do that inside of this board. But if you need a lot of memory, then you'd have to spin the board and add DDR4, which you have 100 I/O lines that aren't used. They're GPIO lines. So you could do it. And that way you could actually support both fourth and C.
I mentioned this company that makes industrial quality Arduino shields, or shields for the Arduino standard. I put the link in the chat for those who are interested. Are we